In this video, we'll show you how to use an S3 bucket as a Kubernetes volume. Now, when I say S3, I actually mean any cloud storage that's compatible with the S3 API. So this includes things like MinIO or Google Cloud Storage. The S3 storage is going to act like a normal persistent volume claim for our pods. This setup is enabled by Datashim, which is an incubating Linux Foundation project. To test out this system in a web browser, you'll want to set up a load balancer service. Behind the service, we'll use a pod that's running Nginx and a cloud storage bucket that contains a custom Index.html file. The demonstrated flow will effectively look like this. Now that you've seen what we're trying to achieve, let's jump into the Google Cloud Console and set things up. Your only prerequisite step is setting up a Kubernetes cluster, which I have done here. Note that almost any Kubernetes environment will work. It doesn't have to be Google Cloud. We'll connect to the cluster using the Cloud Shell and then provision the required resources. First thing, we need to authenticate. Next, you should install the Datashim system. We'll do that with the command of this format. Note that this is going to use the master branch of the Datashim project, not a named release. Check out the project's GitHub README if you need to tune this approach. Next, set the namespaces where you want to set monitor pods for the use of datasets. In our setup, we'll use just the default namespace. Next, let's create the cloud storage bucket. We'll hide the Cloud Shell here and jump back into that later. Navigate to the cloud storage service and then create a bucket. We'll call the bucket Datashim Demo. We can proceed with the defaults for the region and security settings. With the bucket created, you'll now need an HTML file in it. We'll set that up in the Cloud Shell IDE. We'll name the file Index.html and paste in a simple Hello World website. Once you're done, copy the file to your bucket. Okay, now back in the cloud storage service, you'll need to set up S3 API Interoperability. Go to the Settings page and then to Interoperability. We need to create a service account key, and if you don't already have one, create the service account itself here. Leave the project level roles blank since you just want the service account to access a single bucket. Record both the access key and access secret, as you'll need them in just a moment. Then, in your bucket, add the permissions for that service account. You'll probably want storage object admin permissions so that you can both read and write bucket objects within your Kubernetes pod. Great. Now let's create a Kubernetes Resources file for our Nginx website. We'll start with 2 resources in this file. First, we need our dataset. This is where we need to paste in that access key and access secret. We'll also need to provide a bucket name. In the pod, I've actually defined more than we need to here. You can get away with just providing, for example, the bucket mount. Or if you're okay with the default mount location, you can actually just provide the 2 labels at the top. However, just to be explicit and clear, we'll go ahead and fully specify these things in the same way you usually would for a normal persistent volume claim. Once you're ready, apply those resources. Before we expose this pod with a service, let's make sure it's running correctly. It does seem to be working fine, so let's add a service that gives us browser-based pod access. We'll just need to add one more label onto the Nginx pod so that our service maps to that particular pod. Once your service has an external IP, you can use it to access the application on HTTP. There, we can see our Hello World test website, which is coming from our cloud storage Index.html file, as expected. We'll try to answer any comments that you post in the comment section of this video and want to thank you for watching.